morning, students. My name is Joseph Okoth, and once again, welcome to our physics lesson. And today, we are going to look at lenses. Thin lenses. As the name suggests, these are lenses. They are very thin, and they are applied in various fields in our country and even in the field of science. To begin with, this is what you need to understand as a student. One, you are supposed to describe the converging lens as well as the diverging lens. You are supposed to describe, using ray diagrams, the principal focus, the optical center, the focal length, and also the thin lens. You are supposed to determine experimentally the focal length of a converging lens and also locate the images formed by the thin lenses as in the ray diagrams. Again, you are supposed to explain the image formation in the human eye. You are supposed to describe the defects of vision in the human eye and how they are corrected. You are supposed to describe the uses of lenses in various optical devices, solve numerical problems involving the lens formula and the magnification. As introduction, let us define what a lens is. A lens is simply a transparent material that refracts light in such a way as to form an image. They normally operate on refractive property of light. They are made of glass, clear plastic, perspex. They are found in cameras, human eye, spectacles, telescopes, microscope, and projectors. Thin lenses. They are of two types. The convex lens, also referred to as the converging lens. These lenses are normally thickest at the middle and very thin at the ends. And then we have the concave lens, also referred to as the diverging lens. They are thinnest at the middle and thickest at the ends. Then these are the diagrams of the lenses that we just defined. We start with the convex lenses. We have a biconvex lens. As you can see, the two sides are bulging outwards. Then we have the plano-convex, whereby one side is plane or straight, but one side is diverging or bulging outwards. Then we also have the convex meniscus. It looks like the shape of the new moon. This is also another type of convex lens that we have. Then we have the biconcave lens. It has two sides bulging inside, as indicated there. Then the plano-concave lens, one side is plane and the other side is bulging inside. Then we have the concave meniscus that looks like that. So these are the types of lenses that we have in both convex and the concave lenses. Effects of lens on parallel rays of light. What happens when rays strike one side of the lens? As we said, the lens is a transparent material, so light goes through, but the moment it reaches the middle, this light is being refracted such that they are focused at a common point, which we can see in the diagram like that. That is for the convex lens. But when it comes to the concave lens, the rays are refracted in such a way that they appear to diverge or come from a common point, as directed or as shown in the diagram that we have on the board. So these are the two types of lenses and their effect on the parallel rays of light. In lenses, we have some definitions which are very, very important, and we have to go through them. We start with the first one, that is the center of curvature. What is this center of curvature? This is the center of the sphere, which the lens is part. Then we have the radius of curvature, always abbreviated as R, is the radius of the sphere of which the surface of the lens is part. Then we have the principal axis. It's a line joining the centers of curvature of its surface, then optical center, abbreviated as O. It is a point on the principal axis, midway between the lens surfaces. Principal focus, normally abbreviated as capital F, is a point on the principal axis where all rays converge after passing through the lens. While for a concave lens is a point on the principal axis behind the lens from which rays seem to divide from after passing through the lens. Focal length. The symbol of focal length is the small f. Don't confuse with the principal focus. It is the distance between the optical center and the principal focus. Focal plane is the plane perpendicular to the principal axis that all the rays seem to converge to or seem to appear to diverge from. The incident rays in this case are not parallel to the principal axis. Then we have paraxial rays. These are rays that are parallel and close to the principal axis. Then lastly we have the marginal rays. Are rays that are parallel and far away from the principal axis. Those are the terms that are used in the thin lenses. Then we have the lens and the ray diagrams. We start with the first diagram. This one is a convex lens and it converges the rays as shown below. So once the rays are converged to a common point, which is the principal focus, then they extend by again diverging from that particular point. So the distance between the optical center of the lens and the principal focus is what we call the focal length, that distance, and is normally abbreviated as F. We have the principal axis. That is the straight line passing through the optical center of the lens. That is how it looks like. But we have the principal focus of a concave lens is as indicated by the diagram. As you can see, the red rays shows the rays as they are being diverged from the principal focus. Then we have again the same principal axis, but this time with the different rays approaching the concave lens at that angle. So these are some of the points expressed diagrammatically of the principal focus, the focal length of both the convex and the concave lenses. Ray diagrams. These are rays that are used to locate the images. For one to locate the image when using a lens, ray diagrams are of great importance. There are three major rays that are used in ray diagrams for the location of images formed by the lenses. These rays are normally four. We start with the first one, a ray of light parallel to the principal axis. As you can see, this ray is normally refracted such that it passes through the focal point or the principal focus. That is for a convex lens. For the concave lens, the ray is refracted such that it appears to come from a point behind the lens as indicated. So this is the first ray that is used in the location of the images. Then we have the second ray, a ray of light passing through the principal focus. It passes or appears to pass through the principal focus. For the convex lens, this ray that is passing through the principal focus is refracted such that it is parallel to the principal axis. Then for the concave mirror, that ray is refracted again such that it is parallel to the principal axis as shown in the two diagrams. Next is the ray through the optical center. This ray normally passes on undeviated. For the convex lens, it passes straight like that, undeviated. Then for the concave lens, the ray passes on like that. Next, we have the image formation. As you can see, it's important to note the following. 1. Real rays are real images are drawn in 4 lines. Virtual rays and virtual images are drawn in broken or dotted lines. To locate the image, 2 rays from the tip of the object are drawn. Then, should the foot of the object cross the principal axis, the method on 3 above is used to get the foot of the image. The top is joined to the foot to get the image. Up to that point, students, we have come to the end of our first lesson. Till next time, goodbye.